So hello everyone, in the last session we have seen about the Lenz law and we have seen how to calculate the direction of a current due to the different cases, and I hope you are very much confident with that. Now in this session we are going to start the calculation of a induced EMF by using the Faraday's law. Now we are going to learn about the Faraday's law. Basically we have seen everything about the calculation of something called as a direction of current. Now we are going to see about the calculation of EMF, how to calculate the EMF. So let us start the illustration on Faraday's law. That is very important. Illustrations on Faraday's law. Faraday's law. Okay, see, it is a law, there is no proof for it. You have to remember it and you have to solve the problems on it. That is a simple thing. So let us take a very simple problem. Suppose this is the region where magnetic field is there. Okay, and suppose we have a circular coil whose radius is r and the magnetic field is b naught t square. My question, and suppose the resistance is r ohm. You have to find the current, and current means you have to tell me the direction as well as the magnitude. Okay, so let first see, I am doing this question, after that you will do that. See, first, what is the direction? First of all, the direction is very simple. You can see with the time the magnetic field is increasing, correct? As time will increase, the magnetic field will increase, correct? Now the magnetic field increase, so it will try to induce the current in this way such that the magnetic field will decrease. So it will keep like thumb like this and you will curl like this, so you will get a current something like this, correct? Now let us talk about the calculation of this current value. So for that, our first step will be very simple. We have to first calculate about the magnetic flux, that is simply phi b dot ds. What is a magnetic field? Magnetic field is b naught t square. Ds is the area vector, and as you can see, it is a magnetic field is not a function of something distance, it is a function of b dot ds. Ds I can take, and this is cos 0 degree integration, so this will become b naught t square. Ds, integration of ds, this surface, what is the integration? It will be pi r square into 1, correct? So this is b naught t square pi r square. So what is EMF? Don't consider the sign. Negative sign is due to the Lenz law. Why there is a negative sign? You have, if you remember, this is due to the Lenz law because it is opposed, na? So that's why. Okay, so EMF is equal to, just differentiate this, you will get b naught into 2 t pi r square. That is EMF. Now what is the current? Current will be simply b naught into 2 t pi r square divided by r. That is a current. Answer. Clear? So this is the same steps you have to follow in all the question. It doesn't matter what type of question it is given. It doesn't matter. You have to follow the same steps in all types of question. Clear? Any doubt? Let's take one more example. The same question, I am doing a small change and you just calculate and tell me the answer in the next session. Okay, just I am writing b naught t cube. Okay, same question, you have to find the I induced. Okay, everything will be same, direction you have to calculate. Okay, clear? Just note down this question for your homework, for your practice. Clear? Just note it down. Completed? Okay. Next question. Suppose I am taking the same question. Okay, suppose I am taking the same question, but this time what I am asking is changing. In suppose the magnetic field is there, but my question is very simple here. I want to know what is Q flow, means charge flow. Okay, that is my question. Charge flow. How will you calculate? Magnetic field is B naught T. How will you calculate? So everyone will say, sir, first we will calculate the current. Okay, and current we know, sir, dq by dt, and then we integrate. We will take dq is equal to I dt, and we will integrate from 0 to t. Then we can calculate. Simple, sir. There is no problem in time t naught seconds. Okay, simple, sir, no problem. But I am saying there is no need to do this, all these things. Remember, always remember the charge flown how to calculate, that is dq. How to calculate this? This is defined as a delta phi divided by, this is defined as a d phi, sorry, this is defined as a d phi by r, or you can say this is defined as a d phi by r, or you can say the average charge flown, that is what, delta q is equal to delta phi by r. So just use this formula and you just tell me the answer directly. So if you calculate what is a flux, see, flux is very simple. Phi is what? That is B naught into T into pi r square. Suppose the radius is r. Now what is phi initial? Phi initial is equal to 0. At t equal to 0, the phi initial will be 0. Now what is phi at t equal to t naught? So it will be B naught T naught pi r square, correct? So, and the resistance is R, is given, R ohm. So what is my charge flown? Average charge flown dq delta q, that is equal to what? B naught T pi r q minus 0 divided by small r, that is equal to B naught T pi r square divided by small r, correct? Coulomb. This is how you can directly calculate the charge flown. For that you have to remember this concept. This concept is very important. Just note it down, this concept. Please note it down. So whenever we have to ask to calculate the charge flow, we can go by this approach. Now I want to give you one homework problem, and then we can do some more example in the next session. Okay, so let us give you one homework problem, and I hope everyone will solve this. So we have you have two homework problems. If you see, you have two homework problems, and I hope you will do that. Basically this is my center, this radius is A, this radius is B, correct? And obviously A is very less than B. The current in this is I naught T square, and the resistance of this is suppose R ohm, correct? My simple question is that what is I of T in this? That is my question, and this is a homework question for you. Basically why I have given this thing, first you have to think about it, and then you have to do the calculation, and you have to tell me, okay, what is the current induced in this. Approach is very simple. You have to first calculate the flux, and then you have to go for the calculation of d phi by dt. From that you will get the EMF, and then you will get the current I is equal to E by R. If you have enjoyed this session, and if you have liked it, please like it, share it, subscribe it. Have a nice day. Thank you. So basically what you have to do, you have to first calculate the, sorry, galbad ho gaya. First what you have to do, first you have to calculate the flux here, and after the calculation of the flux you have to calculate the rate of change of flux, that is d phi by dt. From there you will get the EMF, and then my current is equal to, simply, what is my current? Current is simply defined as EMF by R. From there you will get the current, and then by using that you can calculate these values. And I hope you have enjoyed this session and you have learned a lot of things. In the next session we will going to solve some more problems and some more examples. Till then, take care, goodbye, have a nice day. Thank you.